Hi everyone, welcome to the IoT show Deep Dive. In this show, we actually cover a different topic every other week to help you build your next IoT solution. What's also great about this show is that we will show tips, tricks, best practices, all based on our past experiences, building with partners and customers with these particular solutions. Another great thing, since it's live, we're actually able to answer your guys' questions. So if you have any questions, feel free to put it into the chat, and I'll go ahead as your host. We'll ask the questions to both of these amazing guest speakers. Which also is great about this is that it is recorded, so if you missed anything, you can go back and watch the recording. All right, let's go ahead and get started. So this week we're actually going to be focusing on location intelligence with Azure Maps. So let's go ahead. I want to introduce these amazing speakers. So whenever anyone has questions in Microsoft about Azure Maps, these are the people that I take them to because they're leading experts on how to work with location intelligence, how to build with these Azure Maps. So I'll go ahead and introduce Ricky, who not only is on the product team, but also apparently you're a worldwide lead for geospatial spatial community here at Microsoft.
That's right. Yeah, we have an internal community inside of Microsoft for people that are interested in geospatial. It's both engineers, it's also the sales and field people as well. And so I lead that community. So if I don't know the answers to your questions, I know someone who does. And so if I can't answer them today, we can take it offline and I can follow up.
Okay, perfect. And then we have Audi here too, who works on the Azure IoT team, as well as all of us actually work on that team, focusing on Azure Maps.
Yes. Hi everyone. My name is Audi Nyman and I'm a senior program manager on Azure Maps, and I'm focusing on our data and services. So whenever you have any questions about our REST services, I'm the point of contact.
Perfect. All right, let's go ahead and get started. So one of the reasons why I really wanted this as a deep dive topic is because when I was coding with partners and customers, a lot of them, when they were going to the Azure cloud, when they were focusing on like asset tracking or fleet management, they really wanted built-in location services natively in Azure, especially since they were switching to the Azure cloud. And so this is a great way for folks to get started with Azure Maps. Just use your Azure subscription and get started. So Ricky, did you want to give us an overview on all things Azure Maps, and then we can start going into the different demos?
Yeah. Let's dive into the deck. All right. So Azure Maps can be used in a whole array of applications. So today we're focusing more so on the fleet management and location intelligent logistics and transportation area, but there's other areas as well. You can use this in public websites like a store locator in the most basic case, or you can use this for business intelligence, and basically anywhere you can use a map, you can use Azure Maps. And not only the maps, but also the services. So we have a lot of analysis services and powerful services that can be used without a visual component, which can be quite useful. So what is Azure Maps? It's a geospatial platform for the enterprise, and so it's Microsoft's primary geospatial platform. We partner with companies such as TomTom and MoveIt. So TomTom brings us all our excellent road and traffic data, and MoveIt brings us the public transit data. And so MoveIt has some of the best public transit data around globally, and so we pull these all in to one central solution, all hosted on Azure. And so, if you have a service hosted in Azure, it directly connects. You can directly connect up to Azure Maps, and everything's running in the same cloud, so you get the best performance and best security possible. We have a number of different APIs and services and SDKs. So from the map control side of things, so we have a web SDK, which is very powerful. It uses WebGL, can render hundreds of thousands of data points, very smooth, has really rich UI. We also have an Android SDK that we just released in preview and has a lot of the same functionality, and we're looking to eventually get parity between the web control and the Android SDK as well. We also have a number of services, so things like routing services and search services, so being able to geocode an address or find the nearest coffee shop. We have the traffic APIs, which not only allow you to overlay the flow of traffic as a coded image on top of the map, but you can also access that raw data and get actual metrics for each individual road segment. You can also access incident data on traffic data, and so the traffic data is actually updated every 1 to 2 minutes depending on the type of data that you're looking to access. We also have a time zone API, which is quite useful if you're creating an app that's being used for booking. So you can imagine maybe you have an app for booking events or for scheduling for deliveries. Knowing where the vehicle is, what time zone they're in, versus knowing the destination's time zone can drastically be very important when it comes to trying to figure out the actual arrival time. Mm-hmm. We also have a geolocation API, which allows you to do things like take an IP address and find its location. We have some spatial operations APIs, which we just released in preview, which allows you to do some deep analysis of data, so things like generating geofences or calculating buffers around data. One of the great things about Azure Maps is, being that we're part of Microsoft and part of Azure, we would definitely need to be GDPR compliant. We also go the extra mile for security, so we offer 2 different ways to authenticate your usage with Azure Maps. One is key-based authentication, which is pretty common across mapping platforms that are out there. But we also added Azure Active Directory authentication for much higher security purposes. So you don't need to worry about people stealing your key and being able to even lock down the map and the data to only certain users if you wanted to. So let's jump ahead here. Take a look at some partner examples. So this here example, LTI, they're using Azure Maps in a smart city scenario, and so they're doing a lot of different things. Like they're overlaying the traffic data here, and we can see the color of the road to show the flow of traffic. But there's also, if you look closer, you can see little signs for like construction and things like that, which is the incident data. They're also pulling in other environmental alert data that they pull in from another source and easily overlay that on top of Azure Maps. They're also tying into public transit data, so they can see where buses are and things like that. They're also overlaying the location of streetlights and the status of the streetlight. So is the bulb burnt out or not? And they have IoT sensors set up for that to track that. And then they also use this here for calculating and visualizing the emergency vehicle corridors. So basically, where the emergency vehicles, where can they travel? Because they don't need to worry about one-way streets, and when it comes to traffic lights, they can go through them, but they do have to slow down just for safety reasons. And so they're able to go through and visualize this and do analysis based on that. Another example here is TagDit, and so they have a pretty interesting scenario where their construction, everything starts off as a blueprint, and that blueprint, a lot of times it's just a piece of paper, and so they go into a central office. They have that taped on the wall. People go and look at it, and a lot of times you need multiple blueprints for a job, and so they'll stitch them together on the wall and tape them up. And if you're out in the field and you need to go look at the blueprint, you have to go back to the office. So that is not ideal. And so they wanted to digitize this process, and so we helped them take that data, overlay it on top of Azure Maps, so you can actually take any image and stretch it over top of the map, rotate it, and what have you. And one of the big benefits of that is not only can you then visualize it on an interactive map right on your mobile device or in a browser, but you can also overlay additional data sets. So you can see here in the image on the left, they started overlaying vector data or line data for I believe this is for a cave system that they had to be concerned about for when they were doing construction.
And I love that you're giving these different examples of different partners. A question that I get a lot, since a lot of the partners we work with is global, is you mentioned GDPR. Mm-hmm. What happens if we have entering a different location like India? What are the compliances that we need to follow? And does Azure Maps handle that for us? Did you want to deep dive a little bit more into that?
I'm going to refer that one to our data PM.
Yes. So currently, right now that we don't have access to India yet, but that is coming definitely on our roadmap.
Okay, yeah. Perfect.
Yeah.
Yeah. So yeah, when it comes to places like India and other certain other countries, there's a lot of geopolitical requirements that need to be met.
Exactly.
And so things like disputed borders and place names, and so we've been working hard to unlock these regions, and we're getting very close for many of these. And the reality is that there's a lot of red tape that takes time that we have to go through with the government compliance and checks before we launch them. So, so India is currently blocked, but will be unblocked in the not too distant future.
Wonderful. So we do handle those regulations, and that way you don't have to spend tons of time thinking about it, because we're doing that in our back end for you.
Yes, exactly. We take care of all that for you, so you don't have to. And so, like, a great example actually is when we do turn on India. If you'll have access to the Azure Maps platform, but if someone's inside of India and they want to view the map, they're only going to see the view that is allowed by the government of India.
Yeah.
So they don't need to worry about turning on the map and accidentally showing the wrong borders and then causing a potential dispute or what have you.
Yeah.
So they don't need to even think about that at any level. That's just automatically handled by us.
Yeah. Great.
Mm-hmm. All right, so going to another partner example here, we have AirMap. For those not familiar with AirMap, they collect a whole bunch of data and provide a whole bunch of services around drones. And so being able to figure out where can you fly your drone, registering where you're going to fly your drone, because that's something you have to do these days, and being able to reserve airspace and see where restricted airspace is. And so we've been working with them to make all these services available on top of Azure Maps. So they have a plugin that you can easily add into Azure Maps if you want to as well. And so when it comes to transportation, we got to think beyond the cars and trucks. We got to start thinking about the next level, which is drones.
Yeah, it's amazing how many questions we get about drones, using those in solution, even with like fleet management. I think there's Amazon was making it popular with they were testing out drones for delivery for packages. Right. And then after that, we've just been getting a lot of questions that are drone related. So it's great that you highlighted the AirMap.
Right. Yeah. So it's quite interesting, because when it comes to like restricted airspace, it's not a simple, like we see a simple 2D map here, but it goes beyond that, where sometimes, like for airports, it's a lot of times it's a cone shape. Because the planes take off and they need area to take off, but if you're depending on your elevation, you don't need to worry, or you'll be outside of that restricted airspace.
Nice.
And then other places are times when a plane's high up, they have a buffer around them, both vertically and around them horizontally, which is their restricted airspace or their airspace, and so you can fly underneath it or above it as long as you're outside of that buffer. Oh,
so it will show you where the buffer is, elevation-wise?
They do have different visuals for things like that.
Oh, that's great. That's great.
All right. So one other thing I wanted to highlight, so we have the Azure IoT solution accelerators, and these are great for any IoT solution because they cross so many different products inside of in Azure IoT. And so Azure Maps is actually in many of these, and so the remote monitoring one is actually a great one where you could use that for monitoring sensors out in the field, or you could, and those sensors could be vehicles that are moving.
Yeah.
And so so it's a nice quick way to set up like an asset tracking type solution if you wanted to. What's quite neat about these solutions is they're open source, and so they're all production quality code, but we make the code available in two different programming languages, both .NET and Java, so you choose which one you want to use. And being that they're open source, you can go through and say, okay, well, this does 90% of what I need. I only need to worry about building that next 10% rather than having to start from scratch. If anything, or actually one other really cool thing is they have a one-click deploy option as well. If it does exactly what you want to do and you just want to tie it up, or if you just want to try it out, there's a one-click deploy, it deploys it into your Azure subscription, and you're ready to go.
Yeah, and we have a lot of technical decision makers who just want like a quick thing of seeing how powerful our services are. So it's actually really great to showcase the solution Accelerators, just because, like you said, it's one click, you get to see it, but you can also customize it too. So you're not just stuck with that one solution for remote monitoring, because lots of times, people don't really like that one click because it normally means it's not customizable.
Right.
Like this is different.
You have the option of as fast and easy as you want, and or as customizable as you want. And it's quite a great starting spot at a minimum.
Yes.
All right. Now I want to jump into the web SDK and some of the demos around there. As I said earlier, a lot of what we're doing with the web SDK, we plan to transfer over into our Android SDK if it's not already there. And a lot of the data that we see is also available directly through our services. So we have the link up here. We'll share that again later, but quite an easy one to remember. Yeah. So let's jump into the samples. So one of the first things I wanted to highlight is around putting data on the map and setting up the map, and then also styling of data on the map. And so the way we've done this is we use this concept of data-driven styling. And so we'll jump into the code here and take a look. But this is the example that we're going to look at the code for. And so we just see 4 circles on the map. They have different scales or different radiuses and different colors. So how do we do that? And so let's start off by taking a look at the very beginning. So we start off by adding a reference to the JavaScript control and to the CSS file for the Azure Maps web SDK. We're currently on version 2. From there, in this example here, I have some mock data. So let's take a quick look at the mock data. So if you're not familiar with the features, points, or what have you here, what we're using is what's called GeoJSON. We created some helper classes so that you don't have to write the full GeoJSON or raw GeoJSON itself, because it can be error prone if you do it that way.
Okay,
so this helps
good.
remove that error proneness and makes it a little bit more readable as well. And so what we have here is we have 4 different data points at different coordinates. And so the coordinates are longitude, latitude, which is pretty standard in the GIS industry because longitude is often associated with the letter X.
Yep.
And so we have X and Y. And each data point has a different set of properties. And so in this case here, we have one that says my radius is 30, and I have a category value called cat1. Whereas the next one says my radius is 40, so it has a different radius value. And it has a category cat2, whereas the next one just says radius 25. So this year, we don't have, all the data is different, and the last one doesn't have any properties.
Yeah.
So we want to style this data, and we need to have fallbacks. We need to look at different properties of the shape and render it differently. Yep. So first, we'll start off by creating our map instance. We pass in the name of the ID for the div that we want to, or of where we want to render the map. We can add a bunch of map options like the center coordinate, the zoom level, and then we specify our authorization or authentication method. And so in this case here, I'm just using a subscription key, and you can just pass that in. It's very simple. But then we also have other ways or several different ways to add Azure Active Directory. So you can use that both in high security scenarios, but you can also use it in a public website in anonymous mode as well.
Yeah, and that was that's in preview, which is also it's. Hopefully, I'm not sounding like I'm in marketing, but there's tons of new features coming in, and that just happens to be one of them. The Azure Active Directory. Yeah, right. Tongue-tied this morning.
So after we create a map instance, the first thing we want to do is add an event that checks for the ready event. We also have a load event. The ready event basically waits until the map has created enough of its context that it's ready for us to interact with it. Because we have to set up a whole WebGL context, load in some resources, and if you access it too early, it might not have everything generated. And so that's why we wait for the ready event. There's also the load event that you can use instead. The load event actually waits until everything has loaded up to the first view, including all the initial map tiles. And so that actually takes 2 to 3 times longer because it has to download a lot more data. So we recommend using the ready event, but if you want to wait for whatever reason until all the tiles for the initial views loaded, you can use the load event instead. From there, what we do is we have this concept of data source and layers. And so we create a data source, and that's where you're going to put your data. And so we create a data source instance, we add it to the map, we then add our test data to the data source. From there, we can connect that data source up to one or more layers. And so the idea, you might say, okay, well, I have this pin, and I want to create it as a circle, or this point as a circle, and maybe I want to then also add an icon on top of that circle. So now we have this bubble layer for the circle, and then we have a symbol layer for the icon. And so we have two different layers, and we can then connect it up to the same data source. And so rather than having to go through and create multiple copies of our data, we only ever have one copy of the data, and we just say, okay, render it with these different ways. So that allows us to support much larger data sets. And so going down here, we see a bubble layer, which we passed in the data source. You can pass in an ID if you want. I would just set this to null. And then we have the color, radius, and some other properties. So for the color value, I could simply just pass in any HTML or CSS color. So I can pass in red, keep it simple. But then if I pass in just a string value or like a CSS color, it'll apply it to everything. But in this case here, I want to make it data-driven, look at the properties. And so we have this, what we call an expression. And so we go through and we say, okay, match and get the category value. If the category value is cat1, make it purple. If it's cat2, make it green. If it doesn't have a category, or we can't figure it, or it doesn't match anything above, fall back to red. And so that kind of falls back to what we saw in the image. Now we look at the radius value. Again, we can specify a number and say, okay, make it 20. And so the radius value in this case here is in pixels. And so but we've also gone through and we made the added an expression. So we have case, and we look for, all right, we want to see, does it have a myRadius property? And if it does, let's get that. And so the two property, or the 2 points we saw earlier that had the myRadius one, we'll actually grab those values. We had one value that had that just said radius, and so it doesn't. It's not going to pick that one up because it doesn't match. So it's going to fall back to the default, and so the default here being 10 pixels. And so, taking all this into context, and we look back at our original sample, we can go through and say, okay, yeah, this here is 40 pixels, and that one is colored green because of the category. Whereas these two here, one doesn't have any properties, the other one has a property of radius, but it didn't match any of our expressions. All right, jumping through to the next example, we're going to build on top of that, all right? So now, that whole data source has a lot of powerful features in it. Not only can we go through and store our data and index it, makes it really quick for us to query, but it also goes through and it has the option for clustering your data. So if you have a lot of data points on the map, you end up just with a blob of icons or pins on the map. And so what we can do is say, oh yeah, turn on clustering, and it'll group these pins together or these points together that are overlapping. And as you zoom in, these clusters will break apart into the individual points. And so what we see here in this example is we got to have a bubble layer showing scaled circles based on the number of points in a cluster. We've also added a symbol layer on top to tell us the number that's actually in the cluster. And we also modified the color based on the size as well. And then we see individual symbols or pins on the map for all the individual locations as well. As we zoom in, so if we zoom in here, we can see that those clusters break apart. So
it's such a nice feature, because just exactly what you said is when you see all of those little pins all over the map, it's hard to read. So this really helps making it nice and clear where there's big clusters.
And like you can imagine, like if we zoom out here to world level, there's a lot of data, even with the clustering, and I can modify it to make it show less. But if you're monitoring a whole fleet of vehicles and someone's zoomed out, they're not going to want to see 100,000 vehicles on the map, because it won't make any sense out of it.
Be one big blurb.
Right. So let's take a look at this example here. So for this one here, I'm actually pulling in a GeoJSON file that's already have data in it. And so in this case here, it's just all earthquakes that have occurred in the last month or the last 30 days. So let's take a quick look at the map again. You see there's been a lot of earthquakes. But the reality is the overwhelming majority are like have a magnitude of 2 or lower, which no one feels. So that's why we're not. It's not the end of the world here. It's just there's a lot of noise that happens. Again, we go through, we set up our map just like before. The one difference here is I've set the style. So I've set the style to night. We have multiple styles, which changes the color of the background or the base map. So here we have night mode. We also have a dark grayscale. We have satellite imagery and things like that.
And you can easily switch through those views. There is tiling. Where you can switch to satellite and
so
map
we
view.
have a UI control if you want to enable that, so we don't turn it on by default. You, as the developer, we allow you to pull in whatever you want. You can also set it programmatically as well.
And one of the things you mentioned is bringing in data, and just wanted to be clear on, if a lot of people are very protective of their data, and they should be, what is kind of the privacy of that when it's Azure Maps is using people's data?
So, when it comes to our client control, so the web control, the Android SDK, any data you put on the map only renders within that client. It doesn't get sent back to the Azure Map server for rendering. So that, in that case, they have full control. We do have other services where they can upload data into our platform, and we lock that down so that only you can access that, only your account can access it, and you can even use Azure Active Directory to lock it down even more. And so the idea for that is you might, maybe if you want to have a file of geofences you want to upload into our platform, you can do that, or if you have custom icons you want to use with our static imagery service, then you can do that as well.
Nice.
And so we take privacy and security very important. So let's take a look at the data source again. So now we see it's a little bit more complex. So the first value, which I've set to null, is I can pass a custom ID if I wanted to, just for identification purposes, but I don't need that. But what I have done is I've said, okay, turn on clustering, so cluster true. And I've decided a cluster radius. And so I say, all right, anything, take a data point, and anything within 45 pixels of that data point, group it as a cluster. And then go to the next unclustered point and do it again. And so that's how the clustering and the logic works. I've also set a max zoom level. So if I zoom in past zoom level 15, it'll stop clustering. It'll just show everything. And so we can modify that as we see fit. But the idea being that if you have clustering on all the time and you zoom in really close to the map, if there's 2 points that are really close together, they'll always be clustered. And so you can imagine maybe you're showing, a whole bunch of vehicles inside of, or on the premise of a property. And they're all parked side by side. They just end up with a big cluster again because they're all so close together. But at the same time, maybe you can, at that level there, when you're zooming in close enough, you can click enough of an icon to get the individual vehicle if you want to. Again, we then take this data source, we add it to the map. And then we create our layers. And so I start off with creating a bubble layer to visualize the clusters. I attach my data source to that. In this case here, I'm using another expression for the radius, but this time I'm using a step expression. And what I'm looking at is the point count. So every cluster has a set of properties on it, and that tell us some information about that cluster. One of them is just a Boolean value saying, is it a cluster? Another one is this point count value, which tells us the number of points that are in that cluster. And so we take that value. If it's between 0 and 20, that's the that'll be or if it's by default it defaults to 20 pixels. If it's getting myself confused here. If there's more than 100 points in the cluster, it'll go to 30 pixels. If there's more than 750 points in a cluster, it goes to 40 pixels. And so that's how we get the different scaling based on the size of the cluster. There's a lot of other different types of expressions we can use. So if we wanted to go through and do something like a linear interpolation, we can do that.
Nice.
And depending on the type of data, like we saw earthquake data earlier, we can also use exponential interpolation as well. For the color, again, I'm using a step one, and I default to green, and I've got a little bit of I'm using RGB color or RGBA colors here because I want to make them a little bit transparent. There is another option where I could make the set like there's an opacity value, but for whatever reason, this sample I decided to set this right on the individual colors. So by default they're green. If there are more than 100 locations inside of the cluster, it colors it yellow. If there's more than 750, it colors it red. And so if we take a quick look at the sample again, we can verify that and say, okay, yeah, there's the red ones, yeah, they're in the thousands. The yellow ones are in the hundreds, and all the green ones are less than 100. I also add this filter, and so the filter basically tells the data source only the data that has that matches this filter should be applied to this layer. And so in this case here, so I'll scroll up a little bit, we're only looking for the data that has a point or the point count value on it. And so that, in this case, will only be clusters. So only cluster data will end up in this layer. I've added a little bit of extra logic in the sample for when you click on a cluster, it'll zoom in, or if you hover over, it'll also change the pointer. So, but we won't dive into that right now. What I can also do is, so I'm going through and I'm adding some more layers, and so I've added a symbol layer. I connect it up to the same data source. In this case here, I'm hiding the image because I don't want an icon for that. All I want is the text value. And so I want to go through, and another property that the clusters have is a point count abbreviation. And that basically just gives us a string value that's nice and abbreviated. So like we saw on the map here, again, we see like 4.2K rather than 4,200.
Yeah.
So it's better for rendering purposes. And so I go through and I've set the text options. I've offset it so that it goes around the center of the circle. And then
sorry to interrupt you. For the symbols, do you have any recommendations on, when people are creating their icons, besides, like, what is the smallest file size or the largest file size that you guys allow? Just anything to help people when they're building these symbols?
Yeah, so when it comes to if you're overlaying data, in terms of data, your computer's really the limit.
Exactly.
The more memory you have, and the more CPU power you have, the more you can render. And it's all we use WebGL, so it's GPU accelerated.
Okay.
So in terms of individual icons or markers, you can easily do hundreds of thousands. We have samples where we have hundreds of thousands of polygons with multiple points, and so in terms of individual coordinates, you can render millions of them.
Okay.
And so, in the code sample site, if someone wants to go through, there is a sample there that shows render large GeoJSON files. It takes a while to load because it's downloading about 170 megabytes worth of data.
Oh my gosh, yeah.
And it renders it all on the map. And
Yeah.
then once it's rendered, you can actually pan and zoom very smoothly because we have a lot of extra power in that data source or class where we go through and we generalize the data when you're zoomed out. So polygons, if it has a million coordinates, when you're zoomed out, only 5 of them are really needed to render that polygon. As you zoom in, it'll show higher resolutions of that polygon. So going back to the sample, so I have one symbol layer here for rendering the cluster account. I've created another symbol layer for just rendering markers on the map, and so it's using the default icons because I haven't hidden it. But I have applied a filter where I'm saying if it doesn't have the point count, then do that. And then the last thing I've done in this case here is I'm importing data from a URL. So there's a lot of different ways you can bring your data in. So it could be a GeoJSON file from a URL, or you can individually add shapes like we saw in the earlier sample where I had data that I created right in JavaScript and pass that in as well.
Can you give an example of why people would choose to take data from a URL versus just loading that data source?
Yeah, so there's different reasons. So if their data is already in GeoJSON format, or if they have a service that turns it into GeoJSON format, then it's easier just loading it in through the URL.
Yeah.
If they have data that's coming from another service and it's already in GeoJSON or in JSON format, not GeoJSON, or maybe it's an XML or what have you, and they have to parse that data, and then they need to go through and translate and convert it into GeoJSON. And so we are working on tools to help you bring in different data file formats. But at the moment, you have to go through and do that conversion yourself. So by putting your data in GeoJSON format and loading it from a URL, it's much easier than trying to go through and have that extra conversion process. So everything will load a little bit faster. So the rest of the sample, like I said, I added a click event so that when you clicked on a cluster, it'll go through and do something. And so in this case here, I'm going through and I'm calculating the zoom level that the next zoom level I need to go to for that cluster to break apart. Because sometimes if a cluster is really big, sometimes when you zoom in at one level, it's so many things are tied together that it hasn't expanded yet. It hasn't broken apart. And so sometimes you might have to go in 2 or 3 more zoom levels. And so this here example shows how to calculate that. Going to the next sample here, we see weighted heat map. So overlaying data as a heat map, it basically take all that dense data, kind of like we saw from clustering, and based on that density, go through and show us a heat map. So where the most dense area is the hottest area. That's great for if every data point has the same value or represents the same kind of information. But if you have data like earthquake data where we have magnitudes, something that has a higher magnitude represents a much bigger earthquake, and so we want to highlight that more than we want smaller ones. And so what we have here is weighted heat maps, and so you can go through and see that. And so we see, it looks like there's been some earthquakes in Alaska, which I can definitely verify. I believe there was some major ones that happened in December, and they're still getting the aftershocks, which are still fairly significant. And so now if we take a look at this, in this case here, I'm pulling in, I'm pulling in a GeoJSON file from a URL, lots of other options to pull in data. And actually, one other thing I'll highlight here just is, I've talked a lot about GeoJSON. Another data format we support is called vector tiles. And so vector tiles is basically what we do with those is the map. To render one copy of the map, it's a large image. If you zoom in and you wanted a high resolution image of the map, if you made it just one image of the whole world, it would be millions of pixels by millions of pixels and petabytes in size. And so to make it so we can render it in a browser very fast and efficiently, we break the map up into this tile grid and then stitch in and only load in what you're viewing. And so you can actually take your data and match that exact same tile system. And so a vector tile will actually take your data as GeoJSON, converts it into a compressed format, and then loads that into the browser, and then we can render that on the fly. And so the big benefit of that is you can actually handle a lot more data compared to a flat GeoJSON file, because everything will already be broken up into tiles, and only that tile will load rather than loading up the whole GeoJSON file that might be global.
Yeah, the latency on that might be more.
So we have some partners out there that are rendering hundreds of millions of rows of data on the map because through the use of vector tiles. So that's another option, but trying to keep it simple here, so we're not diving into that today. But the nice thing is it's a vector tile is just another data source. And so you can actually tie it into the same layering system. So I could easily swap out the data source for a vector tile source and overlay that. So here we, going back to the sample here, we see now we have a heat map layer. We connect it up to a data source again, and like we saw previously, if I wanted to, I could have maybe a cluster layer on top of that if I wanted to show some icons or numbers and things on top of that, all tied into the same data source. So this is a great example of where I have one data source, one copy of the data. So rather than creating a copy for each layer, if I had 2 layers in a lot of other mapping platforms, I have 2 copies of my data, which means I'm using twice the memory. So now I keep the memory footprint small, which allows me to then do a lot more processing. And that's how we're able to get these high numbers in terms of rendering. In this case here, we're seeing for the weight, I'm using an expression again, and I'm going a little bit more complex because we know that the magnitude value is an exponential value in terms of the earthquake ratings. And so what we have here is an exponential interpolation based on the mag property, because that's what the data set is using for magnitude. If the magnitude is 0, I give it a radius or a weight of 0. And if the magnitude is 6, I give it a weight of 1. Anything in between will be a decimal value. So if it's trying to remember my exponentials here.
That's okay.
But it could be like a value of a magnitude of 1 would have a magnitude or a weight of like 0.2.
Okay, that makes sense. Yeah.
With the radius, in this case here, so for the radius, basically the heat map, we got to say how big of does a heat or data point represent on the map in terms of a heat point. And so we have to set a pixel radius. And so in this case here, what I've done is I've actually done a linear interpolation on the zoom level of the map. And the benefit of doing that is as I zoom the map in and out, the actual radius or the heat map actually kind of sticks with the zoom level or with the map, so it kind of looks like the scale of the circle or the radius is almost like affixed with the scale of the map, and so it makes it a much more better experience for this data set. For other data sets, you might want to have it where that as you zoom out, everything bunches up and creates, it doesn't take into consideration the zoom level. And so what will happen is if you zoomed out normally, the hotspot would represent would show millions of points, but then as you zoomed in, each individual point would turn into its own little hotspot, which wouldn't be as significant. So this here makes it so it all stays consistent. So what we see at the high zoom level looks the same when we zoom in. I'm also doing a linear interpolation on the to define the heat map density. So basically the way the heat maps are created is we create this this circular gradient based on opacity, where in the center it's the most or the least transparent, and as you get to the edge, it becomes more transparent. So we go through and we create this gradient. We overlay each data point on top of this little layer, and now we end up with this big, almost what appears to be like a black and white image, but it's based on transparency and showing the density, because everything will bleed through and add up. We then apply a gradient to that, and so based on the opacity, we go through and say, okay, the opacity at this data point is 0.9. All right, let's make that one red. And then we go through in each pixel and do the same thing. And so by using WebGL, we're able to do this very quickly with a filter. We don't have to actually go through and do pixel by pixel.
Yeah, that would take forever.
So this gives you the ability to go through and apply different gradients so it looks different ways.
Yeah.
All right? So one other thing I wanted to highlight is, so everything that we have for our map is driven by services, so all the map data, and you can actually use this data in other map controls. Like our map control is great, we love it if you use it, but if you decide, hey, I've already got an existing application and it's using Leaflet, which is a very popular open source application, go ahead, take our map control or map data and use it in there. And we have code samples that show how to do that, and there's several different examples out there for different map controls.
I love that, especially as you mentioned, if you already have that existing app, maybe on OpenLayers or anything like that, it's so easy to kind of migrate and use that our services still. Right.
And the approach we're taking is services first, and we want to have a nice rich client experience, but if you already have something out there, why not use it?
Yeah. And sometimes you don't want to duplicate that work. Yeah.
Exactly. All right, so let's switch back to the slides here. So I want to talk about our spatial operations, which is a new set of services inside of Azure Maps. And we're just starting to dive into some of the functionality in there. So you can do things like calculating the closest points to a certain location, calculating a buffer. So a buffer is, you can imagine, like we see here in the top right image, we have a line that represents a power line. But there's an area around it, which is actually a buffer. And in this case here, this is being used for vegetation management, where if there's any trees within a certain buffer or a certain distance of the power line, those trees need to be trimmed and regularly maintained, so that if a storm comes and the tree falls, it doesn't take out the power line. We have other things like doing point and polygon calculations. Like some of these things can be done on the client, but if you have a large data set, it's much better to do it on the server, and we provide a service for you to do that rather than you trying to figure out how to get that to work in your environment, especially if you're doing IoT things and maybe you're running it on the edge is just not an option if it's a large data set, or if maybe you're using different programming languages and you can't find a library that works for what you need, you can just pass it into a service. We also have simple things like the great circle distance, getting the straight line distance between 2 points. But one of the bigger features that we added was the geofencing capabilities. And we see an example here in the bottom right corner of the of fence, which is the red dashed line there. And with values, or in this case here, this is construction, and so we see different equipment that is inside that is green. We have a couple blue icons, which are icons that maybe we're tracking. We want to know when they're close to the geofence, because we would say, oh yeah, we got a dump truck about to show up, or a cement truck. Let's, it's 15 minutes out. Let's make sure we're ready for that, and make sure that we've got a path cleared so we can go through. They can dump their load, and we can get them out of here, and we can get working. But then we also see a red icon where one of the pieces of equipment that's supposed to stay on site has left the site, and so. In that case there, what we can do with geofences is we can monitor when things are in and out of these geofences, or when things are near the geofence as well. And we can go through and then trigger events. And so all this can tie into the event grid inside of Azure as well. And so from there, you can go through and maybe when that event fires, maybe you send an email, maybe send a text message, or maybe you tie into an Azure function. And there's a whole bunch of things already set up in Azure, in the event grid there in Azure that from the Azure Maps side we didn't have to worry about, because all we had to do was connect up to Azure, or the event grid, and from there you can use anything that already exists. So let's take a quick look at what that looks like. And so here's an example here where we have just a simple circle as a geofence in this case here, and we're going to start here, and we're going to go through and travel. So now we see this vehicle traveling along the route, and it's going through and trying to check. It's constantly checking in the background to see if it's near the fence. And there we go. We see a notification. You have now entered the fence, and you've now arrived at your destination. We can go a little bit more complex, and maybe we go through and we want to draw a custom fence where, like we saw earlier, could be the construction site. And then maybe we want to even add a buffer to that as well. So we want to know when they're getting close to that area and when they've entered that area. So now we go through and we play this again, and we're going to see first a notification saying that they've entered the buffer, and then we'll see another notification saying that they've entered the fence. And so there's the first one about the buffer, there's one about the fence, and now you've arrived at your destination.
Yeah, that's really nice that you can set those buffers just so you don't have to, it's easier to get notifications that way. I can imagine if you're, doing fleet management, how important that will be on if you just want that particular region. Okay, that's great. And so we've primarily looked at or seen here is just an event being fired when you've entered a fence. There's also events set up for when you exit a fence, which is great for that construction scenario where the a vehicle has left the property that it shouldn't have. So it's great for from construction. It's great from a security point of view, but there's a lot of other cases as well where geofences become quite useful. And you can you have multiple locations that you're, putting a polygon around and
so for geofences, you can pass a file with thousands of fences.
Okay, perfect.
And so so you don't need to monitor individual construction sites in that example. We could actually monitor all our construction sites that are throughout the whole city in different spots or what have you. There's lots of functionality there, and we have a lot more coming there too. So now I'm going to switch it over to Audi to talk about our services.
Okay. So first, just a quick overview about our search services. So like you can see, we have multiple different search services. The main ones that I want to highlight now is the address search. So that you have a situation when you know the addresses where you want to go, but you don't know the exact coordinates for those addresses. So then you can use our search address service. But then sometimes you might have a situation that you have a big file where you have a bunch of GPS points, and you need to know the address for those points. So then you can also use our address reverse service to get the addresses for those points. And also I want to highlight our POI, point of interest search. So you might want to know where our specific business, for example, all the coffee shops close by. And to do that, you can also use our Search Nearby API. So you know where you are, and you want to know that, hey, within 1 mile radius, give me all the coffee shops. And what we also have is you can search POIs by category. And also what we have now in preview is that if you have a bunch of addresses, so you can also use our batch services. So instead of having one GET request for address, you can submit a batch, and inside that batch you can have up to 10,000 addresses. And that also works for the reverse geocode. And then also you can search points inside the geometries. Yeah.
One service here that I wanted to highlight as well that I thought was pretty cool is the reverse cross street. I've worked with companies that are kind of like the roadside assistance, and the tow truck driver needs to know a landmark or an idea. Like if you tell them, the address, the specific address, the user may not even know that. But the user's on the phone, and maybe they don't have the GPS or what have you, and so they just say, "Oh yeah, I'm near First and Main," and so with the reverse cross street, they can or the user can actually find that out pretty easily. Where even if they don't know the area, they take that GPS point and it goes through and tells you the nearest cross street. So yeah, that one is also quite an interesting one as well.
Yep.
All right.
Yeah, then the search and then route. Okay.
Oh.
Yes.
There we go.
So for the route services, so also you can do routing with our services. For example, you have a fleet and you want to know that these vehicles should go from point A to point B during the day. You can define when this vehicle should leave. You can tell that, hey, it's a truck. What is the size of the truck, the weight, length, and based on that we provide you the optimized route to get to your destination. And also there's other options, so you can say how hilliness the road is, and is it using a fuel or electric to get the charging the vehicle. And next I will show you an example for the routing.
Yeah, a couple other things to highlight on there. So like you may have said, maybe I missed them. So you can pass into up to 150 waypoints. Yes. So you can go from point A to point B to point C to, I think it's, what is it? It ends up being like CB if you use the Excel the format for numbering. So you can pass in a lot of waypoints, and you can also do traveling salesman where the start and end points stay the same, but it will optimize all the points in between, which is quite a powerful feature. Yeah.
So that's actually our next example, the route waypoint optimization.
All right, so let's take a look at your examples there.
Yes, so now we have a situation that at the beginning of the day, you know that, hey, I have these 9 points or 100 points or up to 150 points where I have to go. And what would be the optimal route to do that? So we have the option just to use our routing API so that you can calculate the route, and it will give you the optimized route, so it will go through all these points. But this is not always necessarily the best and the optimal route for you. So we have also the option to do the calculate waypoint optimized route, so then it optimizes the route by the best order. So now you can see that the distance is over 140 kilometers. But when we do the waypoint optimized route, then now the distance is about 90 kilometers, and also now the points are ordered based on the optimal stops. So you have option that in your input you might know that this is the order that I want to go and stop, or then you can use our algorithm to do that and give you the optimal route. And here in the Postman now I have an example how to build query like that. So within the query, you can have all the waypoints, and now there's a colon separating each waypoint. And then I have an option to compute the best order. So now it means that I'm returning the route in the optimal way, and I have selected that now the route type should be the shortest one. It could be also the fastest. And my travel mode is car, and I have now selected compute travel time for all. And I will quickly show you why I did that. And also I have defined that I want to get the instructions type in text format so that it's human friendly. Wait to read. And now when I'm sending the query, so now we can see here the summary for the route. And at the moment there's no traffic delays. But here I can see that what's the length and the travel time in seconds. And now, because I didn't define what is the departure time, so it's the time now, but I could say that, hey, I want to go tomorrow. So then it will be calculated by the historic travel time using that information to give me the estimated travel time. And here in the response, I have a summary for each legs within that route, and also if I put now on all the points for the route, and also if I scroll down, then I will see the instructions.
Very detailed route.
Yeah.
Yes, very detailed. And now here we start to see that, hey, turn right, turn left.
Yeah. And what I love about our routing features is the fact that if you're doing fleet management, sometimes you'll have like cars where they can navigate other parts of the roads where semi-trucks can't. And so I think it's really nice to be able to show what is the great route for a semi-truck who might not be able to go under lower bridges and have those options of having the right route for a particular vehicle. And yeah.
Right.
Exactly, and also if you have some hazardous cargo, for example, so you can give that as an input.
Mm-hmm.
Yeah.
Good. So now and then, the second example I have here to show is to calculate the isochrone, also known as a route range. So here is an example to show the output. So I know that I'm in a specific location, and as an input parameter, I might have that, hey, within 5 minutes where I can go, or I know that I have this amount of gas left, how far away I can go, or I have this amount of electric in my car.
Yeah, that's what. Yeah, I want to highlight that. That's a really powerful feature. Where most services out there that do isochrone or route range are distance-based or time-based. But we have the time-based one, but we also do the range-based. Where, all right, I'm an electric vehicle. I have so much charge. Here's all the parameters around the efficiency of my electric vehicle. Mm-hmm. And it takes all that into consideration and generates that isochrone, which is a really powerful thing. I hadn't seen that anywhere else before, so yeah, it's a really cool feature.
Yeah, I have here an example actually how you can build and query when your vehicle engine type is electric. So here I have now selected that the travel mode is car and the engine type is electric, and then I know there's a bunch of input parameters you have to put here, but or you can just use the time. But now I wanted to highlight how to do it with electric vehicles. So I know what is my energy budget within kilowatt hours, and also I know that how much I have energy left, and also what is the max charge for my vehicle. And then I might say that the route type, it could be the most environmental friendly one, or fastest, or shortest, or thrilling. Now I'm using the eco mode. And also what is the average consumption based on the speed. And now when I'm sending this query, I can see that I get back the reachable range. So I have here the center point for the isochrone, which is now this one here. And then I also get back the boundary information for the isochrone in JSON format. And in the next step, what I can do with the isochrone is, for example, that I might want to search all electric vehicle stations within that isochrone if I have to go and charge. Or I want to find all the coffee houses within that isochrone. That could be also another example. And I can leverage our POI search for that also. And now in this example, I have searching for electric vehicle station.
Yeah, I want to find all the coffee shops.
Yeah, that's what I was thinking. It's like, that's a perfect scenario that you just described. Get us awake in the morning.
Yes.
Yeah. And what's great about everything that is being shown today, we have a lot of great samples. You were showcasing that site here. Yeah. Let me go back to your your screen. We showed the Azure Maps samples. There's about 105 code samples. And what's nice is you can see the demo. You don't even have to put it in your Azure description. You can actually just see it working, and then you could take that code and put it in your own application, which is it's really nice to have all those samples. Ricky, I think you did a big chunk of those samples. Is that true?
Yeah, basically, if anytime someone asks a question that requires more information than just a simple email response, if I think it needs a sample, and I'll create it and add it to the sample site.
Yeah, it's nice. It's completely the code is open source, so you could just go ahead and take it from GitHub or just grab the code from that sample directly. So we knew we were going to get this question, so we're going to go ahead and jump into Q&A for the last 3 minutes. A question we get a lot is, how's this different from Bing Maps? Because you have Bing Maps and Azure Maps. Could you?
Well, I hope some of what we presented helps those who are familiar with Bing Maps see the difference. So Azure Maps is Microsoft's enterprise mapping platform, and it's really what we recommend customers use. It provides a lot more power, a lot more functionality. If you're using Azure, it just makes sense because you go through and you just use your Azure subscription to connect. You don't need a separate license for it. So it's a lot easier in that regards. In terms of what we've been doing and where we're going, it goes way beyond what we were doing in other mapping platforms in the past, and really focusing in on enterprise scenarios.
Okay, well, thank you. Thank you for giving that overview. I think that was our main question, and then we did have questions about upcoming deep dives. So if you have any topics you want us to cover, definitely add us at Twitter. I'm hello techie, hello_techie. So you can go ahead, use hashtag IoT show deep dive, and we'll pick that up for you. Any additional resources, you can go, we have a lot of pages, landing pages about Azure Maps. We also have upcoming shows that we show on IoT Show every Monday, and these deep dives will be every Wednesday. So Ricky, Adi, what are any last advice that you want to give to folks who are building solutions and really want to be using Azure Maps?
Well, the easiest thing is start off at azure.com/maps. You can find all our details from pricing to links to the documentation. Definitely check out that sample site when you go to build your application. If you're using web, we also have samples that are separate from that for Android as well, because we can't run those in the browser, of course. And then monitor our blog. We have regular announcements and a lot of we're a growing platform, growing really fast. Like you said at the very beginning, we only GA'd in May, so it's not even a year yet. And what we've shown today is just what we've released publicly. It doesn't show all the stuff that we've been working on in the back end that that we're going to be announcing as we go forward. So it's lots of exciting things coming.
And also see our tutorials and how to guide how to start to use Azure Maps.
Yep, and you can find those through those links, and I will make sure to post these slides on Azure IoT Tech Community. So thank you everyone for joining. I'm really excited that Ricky and Adi got to join us and give us an overview of Azure Maps. Okay, thank you.
Thank you.
Thank you.